Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating historical artifact, a Nokia Corporation presentation analyzing the launch of the original Apple iPhone. Get ready for a blast from the past.
Oh, this sounds juicy. Was this a post-mortem, a competitive analysis, or what? I'm picturing some serious furrowed brows at Nokia HQ in 2007.
Exactly. It's described as evaluating the iPhone and its implications for Nokia. Think, oh crap, what do we do now? The presentation's from the Nokia Design Archive, so it's likely internal. And it's dated somewhere between January and December of 2007. Pretty specific time frame, huh?
Right. So they weren't just casually observing the iPhone's launch. This was a full-blown strategic assessment. I bet it's packed with insights into Nokia's thinking at the time. What else do we know about this document?
Well, it's listed as an asset in the Atalalto University repository. It's got a rather unique ID number too. 92674OC751654390AA02005AEB4D4D5. I hope I got that right. They even mention a related document. Row the 10th of January 2007.pdf. Sounds like someone was busy that January.
iRow? What's that? Is it some kind of internal code? This is getting interesting. And the license is CC BY-NC North Dakota 4.0, so we can't just go around remixing it and selling it, unfortunately. Shame!
Yeah, I see. It's probably some internal Nokia designation. But the fact that this document even exists is a goldmine. It gives us a window into how a major player in the mobile market reacted to the iPhone's disruptive arrival. Imagine the boardroom discussions. Probably a lot of uh-ohs and what-ifs.
I bet. It would be fascinating to see what specific aspects of the iPhone they were analyzing. Was it the touchscreen? The App Store? The overall user experience? All of the above, I imagine.
Precisely. It's a shame we don't have access to the actual presentation itself. But the metadata alone tells a story itself. It shows how seriously Nokia took the iPhone's launch and how they were trying to understand its potential impact. A valuable lesson in competitive analysis, even today.
Absolutely. This is a great example of how historical documents can shed light on pivotal moments in tech history. It's a reminder that even giants can be blindsided by innovation, and that even giants keep detailed records of their failures.
You're right. And that's all the time we have for today's Tech Bytes and News. Thanks for joining us. We hope you enjoyed this little trip down memory lane. Until next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into the fascinating world of kissing spheres, specifically, a recent breakthrough in understanding how many spheres can touch a central sphere in higher dimensions. It's a problem that's been puzzling mathematicians for centuries.
Centuries? Wow. So this isn't just some trivial geometry problem? I'm intrigued.
Oh, far from it. It all started way back, apparently, with Newton and Gregory debating star orbits. They stumbled upon this kissing number problem. How many identical spheres can touch a central one without overlap? In 3D, it's 12, proven only in 1952. Imagine the arguments those guys had. Newton was right, by the way.
12? That seems surprisingly low. I'd have guessed more. And what about higher dimensions? Does it just scale up proportionally?
No. That's where things get wild. In 2D, it's 6 think pennies around a central penny. But beyond 3D, it's a nightmare. Dimensions. Dimensions 4, 8, and 24 are solved, thanks to beautiful, symmetrical arrangements. But the rest? A total mess were signed. We're talking estimates with huge gaps between upper and lower bounds. Millions of spheres could potentially fit, and we don't know for sure.
So mathematicians were stuck, using symmetrical approaches? sounds like a classic case of tunnel vision.
Exactly. Enter Anki Lee, an MIT undergrad. She decided to break the mold, literally. Instead of focusing on perfect symmetry, she looked for weirder structures. She started with a known lattice, the Barnes wall lattice, and flipped some signs. A deceptively simple change.
Flip signs? What does that even mean in this context?
It's related to the error-correcting codes used to represent the sphere centers as points. Think of coordinates. Changing a sign changes the position of a sphere. It's a subtle shift, but it created gaps where more spheres could fit. She initially doubted herself, thinking it was a mistake, but it worked. Amazing!
That's incredible! So she essentially introduced controlled disorder to find a better solution? That's a really clever approach.
Precisely. She and her professor, Henry Cohn, improved the lower bound for the kissing number in dimensions 17 through 21, the first progress in those dimensions since the 1960s. They used computer simulations to verify their results, of course. But the method itself is groundbreaking. It shows that sometimes breaking the rules leads to better results.
It's a fantastic example of how sometimes a little bit of chaos can lead to order. And it highlights how much we still don't understand about these seemingly simple geometric problems. Fascinating.
Absolutely. Their work is a testament to the power of unconventional thinking and the enduring mysteries of mathematics. And it opens up a whole new avenue for research. The kissing problem is far from solved, but we're definitely getting closer, one unexpected sign flip at a time. Thanks for joining us on Tech Bytes and News. We'll see you next time for another dose of tech news and mathematical marvels. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of memory management in C. Think of it as a thrilling detective story. But instead of clues, we have pointers. And instead of a criminal, we have memory leaks. Exciting, right?
Absolutely. I've always been a bit hazy on the details. So, what's the core mystery we're unraveling today?
The mystery, my friend, is how C handles memory allocation without the safety nets of languages like Rust. We'll explore the stack, the heap, malloc, realloc, and the dreaded, free, the functions that make or break a C programmer's sanity. We'll even touch upon the art of avoiding those pesky memory leaks.
Sounds intense. Let's start with the basics. What's the difference between the stack and the heap?
Think of the stack as a neatly organized stack of plates. LIFO. Last in, first out. Each function call gets its own plate, holding local variables. Yes, it's fast and efficient, but the size is fixed. The heap, on the other hand, is a giant, messy pile of plates. You can grab a plate of any size, but you need to keep track of where you put it. It's more flexible, but slower, and prone to errors if you're not careful.
I see. So, malloc, is like grabbing a plate from the heap?
Precisely. Malloc, reserves a block of memory on the heap. Realloc, lets you resize that plate if you need more or less space. And free, is putting the plate back. Crucial to avoid those memory leaks.
And what about those memory leaks? How exactly do they happen?
Memory leaks happen when you grab a plate from the heap but forget to put it back. The program loses track of the memory, and it's wasted until the program ends. It's like leaving a plate on the table after a feast. Eventually, you'll run out of clean plates.
That's a pretty vivid analogy. So the article also mentions fragmentation. What's that?
Fragmentation is like having lots of tiny, unusable spaces between plates on the heap. You might have enough space in total, but no single space big enough for what you need. It's like trying to fit a large casserole dish into a cupboard full of small bowls.
Got it. And the article talks about a use after free UAF bug. That sounds scary.
Oh, it is. It's like trying to use a plate that's already been washed and put away. You might get lucky and it works, but it's highly unpredictable and can lead to crashes or security vulnerabilities. It's a very common problem in C.
Wow, this is way more complicated than I thought. The article even mentions that malloc, itself isn't magic. It needs to manage its own bookkeeping. How does it do that?
Exactly. Malloc, Uses some of the heap to keep track of which memory is free and which is in use. It's like having a waiter who keeps track of which plates are clean and which are dirty. There are clever data structures used for this, but the basic idea is to maintain a list of free and allocated blocks.
So in essence, memory management in C is a delicate balancing act. One wrong move, and you're dealing with leaks, fragmentation, or UAFs. It sounds like Rust's stricter memory model is a welcome relief.
Absolutely. Rust's ownership system and borrow checkers are designed to prevent these kinds of errors at compile time, making it much safer. But understanding the underlying mechanics in C is crucial for anyone working with lower-level systems programming. That's why this article is so valuable. It gives you a glimpse under the hood.
I agree. This has been a fantastic overview. Thanks for breaking down this complex topic.
My pleasure. And remember, folks, always free your plates. Until next time, this is Tech Bytes and News, signing off.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving headfirst into the exciting news that Intel's Tofino P4 software is now open source. It's a game changer, folks.
Whoa, open source Tofino? That's huge. I'm already picturing the possibilities. What's the main impact here?
Exactly. It's not just about licensing. It's about democratizing access to incredibly powerful networking tools. Think of it. Programmable Ethernet switches, previously locked behind closed doors, are now open for anyone to tinker with.
So any aspiring network engineer, even a student, can now get their hands dirty with production-grade code? That's incredibly empowering.
Absolutely. It's a massive boost for education, research, and innovation. Imagine the breakthroughs we'll see from startups and universities now that they have access to this level of technology. It's like giving everyone a supercharged network toolbox.
I see. But what about the practical aspects? How is the code organized? Is it user-friendly?
Good question. The code is split across two main repos within the Fee4Lang structure. There's the P4C repo with compiler components, nicely organized into subfolders. Arch, Common, Control Plane, and so on. And then there's the Open-4 Studio repo, with the rest of the Tofino P4 Studio tools. It's pretty well structured from what I understand.
So it's not just a random dump of code? There's actual structure and documentation? That's reassuring.
Exactly. They've put a lot of effort into making it accessible. Plus, it's not just Intel working on this. The P4 Technical Steering Committee, with folks like Fabian Ruffy and Andy Fingerhut, were involved. That's a serious endorsement of the project's quality.
That's impressive. So what's the call to action here? What should the listeners be doing?
Well, first, spread the word. Tell your friends, colleagues, anyone interested in networking. Second, dive into the repositories. Explore the code, learn how it works, and contribute. Even small contributions, like fixing bugs or improving documentation, make a difference. This is a community effort, and everyone's participation is valuable.
It sounds like a fantastic opportunity for anyone interested in programmable networks. It's really exciting to see this level of collaboration and openness in the networking world.
Absolutely. It's a huge step forward, and it's going to have a ripple effect across the industry. We're talking about accelerating innovation, empowering developers, and ultimately, shaping the future of networking. It's a thrilling time to be involved.
Thanks for breaking down this exciting news for us.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you found this insightful, and we encourage you to explore the Tofino P4 open source project. Until next time, goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into the wild world of setting up a Banana Pi M7 as a KVM hypervisor with ZFS on Debian. Buckle up, it's going to be a bumpy ride.
A Banana Pi M7? Sounds fruity. But seriously, what's the appeal of using such a board for a hypervisor? I mean, isn't that usually a pretty beefy server task?
That's the beauty of it. This little guy packs a punch. 8 cores, 4 A76s and 4 A55s. Plenty of RAM options. And even PCIe 3.0 for an NVMe drive. Perfect for a small-scale private cloud, or Kumotate, as they say. Imagine a homegrown cloud, all from a single board.
Okay, I'm intrigued. But the article mentions some compatibility headaches, specifically with the kernel and NVMe drives. Sounds like a recipe for frustration.
Oh, absolutely. The RK3588 is relatively new, so kernel support isn't perfectly smooth sailing. They had to use Armbian, a custom Debian build, to get things working. And the NVMe compatibility? Let's just say it's a bit of a lottery. Some drives work flawlessly, others, not so much. Power supply is crucial too. You need more than your average 5v3A.
So which kernel version did they settle on? And why Debian Bookworm?
They went with Debian Bookworm because of the ZFS version. Ubuntu's OpenZFS 2.2.2 doesn't play nice with newer kernels, but Debian Bookworm's 2.2.7 supports up to 6.12. They used the current Rockchip RK3588 kernel, version 6.12.0, which worked like a charm. It boots!
Ah, the joys of kernel versioning. So they built a custom Armbian image. Did they do this on the Banana Pi itself?
Nope, that would be unwise. They used a regular x86-64 machine, leveraging QEMU emulation to build the image in a Docker container. Clever, right? Avoiding the need to install all the build dependencies on the host machine.
And once the image was built, they flashed it onto a micro SD card, right? And then what about storage for the VMs?
Precisely. Micro SD for the OS, and then they use that NVMe drive for a ZFS Z-pool. ZFS for the win. Checksums for data integrity, snapshots for easy rollbacks, and it integrates nicely with libvirt. Fantastic.
But ZFS isn't without its downsides, is it? Performance overhead, for one.
You're absolutely right. There's a performance trade-off. But for the added data integrity and features, they felt it was worth it. Plus, they used encryption with the Z-pool, leveraging the existing LUKS encryption on the root file system for the key. A bit risky, but convenient.
Risky indeed. Storing the encryption key directly on the root file system? That seems like a single point of failure. What about libvirt setup? Was that straightforward?
Relatively. They installed the necessary libvirt packages, including the ZFS storage driver. Then, just to test, they spun up a Debian VM using /virt install /. It worked! A testament to their hard work.
So in the end, a successful, albeit slightly adventurous, journey into the world of embedded hypervisors. Thanks for walking us through this. It's certainly given me a new appreciation for the power of these small SBCs.
My pleasure. And remember, folks, always back up your data. And if you're attempting this at home, be prepared for some troubleshooting. But the reward of a self-hosted cloud on a Banana Pi? Priceless. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of Linux security, specifically a presentation titled, What Every Hacker Should Know About TLB Invalidation. It's a real page-turner, I tell ya.
A page-turner? Is this a thriller? I'm expecting something more technical, not a nail-biter.
Oh, it's very technical, but the twists and turns in the TLB invalidation process are surprisingly dramatic. Think of it as a high-stakes game of virtual memory chess. We're talking about the translation look-aside buffer, a crucial component of virtual memory management. It's basically a cache that speeds up address translation, but it's got some quirks.
Quirks? Like what? Does it have a secret life? Does it go on midnight raids to steal physical addresses?
Almost. It caches successful page walks, but it can also cache translations from speculative execution that never actually happened. It can even hold multiple translations for the same physical address. And the Intel SDM, the Bible of Intel architecture, is delightfully vague about the details. It's a wild west out there.
So if the TLB is caching things it shouldn't, what's the big deal? Why do we need invalidation?
Because inconsistency between the TLB and the actual page tables in memory is a recipe for disaster. System instability, security vulnerabilities, the whole shebang. The presentation goes into great detail about when invalidation is necessary, modifying page tables, context switching, and so on. It's a delicate dance.
A dance? I'm picturing a ballet of bits and bytes, all perfectly synchronized. but I'm guessing it's more like a mosh pit of memory management.
More like a mosh pit, yeah. The presentation also discusses hardware optimizations like global pages and PCIDs, which are designed to reduce the need for invalidation. They're like fancy footwork in our memory management ballet, or mosh pit, whichever you prefer.
So these optimizations make things faster, right? But are they foolproof?
Not quite. The presentation details a fascinating case study involving the PAX/GR Security Private KSTA-CKS feature. This feature enhances kernel security by making kernel stacks private to each task. A seemingly simple improvement, but it led to some very strange behavior on newer Intel CPUs.
Strange how? Did the stack start doing the tango?
No tango, but there were inexplicable page faults and even rare kernel stack corruptions. It turned out to be a subtle interaction with the CPU's paging structure caches. Those caches for higher-level page table entries. The caches were holding onto stale entries, leading to the problems.
So the optimization itself caused a problem? That's a bit ironic, isn't it? Sounds like a case of unintended consequences.
Exactly. It highlights the complexities of modern CPU architectures and the challenges of maintaining coherency between hardware caches and software-managed memory. They even found a bug in the INVLPG instruction on some Intel CPUs, which further complicated matters.
Wow, so even the instruction meant to fix the problem was broken? This is getting wild.
It's a wild ride, my friend. The presentation concludes by emphasizing the complexity of maintaining coherency, the ambiguity of documentation, and the fact that sometimes what seems like a CPU bug is actually just a very obscure corner case. It's a reminder that even in the seemingly well-defined world of computer architecture, there are still plenty of surprises lurking.
So the moral of the story is, don't trust the TLB, always invalidate?
Well, not always invalidate, that would kill performance. But understand the complexities, be aware of the potential pitfalls, and always be prepared for the unexpected. And maybe, just maybe, invest in a really good debugger. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the sometimes chaotic world of TLB invalidation. Until next time, stay curious.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the incredible, heartbreaking, and ultimately inspiring story of Matilda McCreer, the last known survivor of the transatlantic slave trade. Get ready for a roller coaster of emotions.
Whoa, that's a heavy topic. I'm already intrigued. What makes Matilda's story so unique?
Well, for starters, she was the last known survivor of the Clotilda, the last ship known to have transported enslaved Africans to the U.S. Imagine a two-masted schooner carrying 108 souls in horrific conditions across the Atlantic. It's chilling.
108 people crammed onto a small ship. That's unimaginable. And what happened after they arrived in Alabama?
They were sold, of course. Matilda, originally named Abake, and her family were forced into slavery on a plantation. The brutality of it all is just staggering. But she was incredibly resilient.
Resilient is an understatement. The article mentions her making a 15-mile trek to court in her 70s to seek compensation for her suffering. That's sheer determination.
Absolutely. She walked 15 miles to court to claim compensation for the horrors she and her family endured. Unfortunately, her claim was dismissed. The injustice is palpable.
So she never received justice in her lifetime? That's infuriating. But her story wasn't lost, right? I mean, the article mentions a historian finding her story.
That's right. Hannah Durkin, a historian, unearthed Matilda's story from a local newspaper article. It's a testament to the power of historical research and the importance of preserving these narratives. It's also a reminder of how easily these stories can be lost to time.
It's amazing how one small article can reveal such a monumental story. It highlights the importance of local archives and journalism. What about Matilda's later life? What happened after the Civil War?
Even after emancipation, Matilda faced immense challenges. Sharecropping, essentially a form of indentured servitude, kept her and many other formerly enslaved people trapped in cycles of poverty. The system was designed to keep them down.
It's horrifying how quickly the freedom promised by the Emancipation Proclamation was undermined by systemic racism and exploitative practices. It was slavery in all but name.
Precisely. The black codes, convict leasing, Jim Crow laws, all designed to maintain racial hierarchy and control. Matilda's life was a constant struggle against this system, and yet she persevered.
Her grandson, John Creer, also played a part in the fight for civil rights, didn't he? The article mentions him being arrested for defending himself against a racist attack.
Yes, John Creer, Matilda's grandson, was actively involved in the civil rights movement. He carried on the fight for justice that his grandmother started. It's a powerful intergenerational story of resilience and resistance.
It truly is. Matilda's story is a powerful reminder of the lasting impact of slavery and the ongoing struggle for racial justice. It's a story that needs to be told and retold.
Absolutely. Matilda McCreer's life, though marked by immense suffering, is a testament to the enduring human spirit. Her story is a powerful reminder of the past and a call to action for the future. Thanks for joining us on Tech Bytes and News. We hope you found this discussion as moving as we did. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating post about a game developer's 2024 experiences, a year filled with ambitious projects and valuable lessons learned, even without finishing a single game. Ready to jump in?
Absolutely, I'm buzzing with anticipation. So this developer tackled 3 projects, right? What were the main takeaways?
Exactly. 3 very different games. First, there was Kinship, a multiplayer turn-based RPG. Think Baldur's Gate meets Slimes? The biggest hurdle? Scope creep. He bit off way more than he could chew, with multiple classes, levels, and, oh boy, the isometric art.
Isometric art is a beast, isn't it? I've heard horror stories. 4 versions of every asset, that's insane. Did he outsource any of that?
Nope. He tried to do it all himself. He learned that lesson the hard way. He also underestimated the time needed to learn multiplayer mechanics, even with his background in networking. Testing alone became a massive time sink. It's not just coding. It's the testing, the debugging across multiple clients. A whole different ballgame.
Totally. That's a common pitfall. And he also mentioned polishing too early, focusing on lighting and shaders before the core gameplay was solid. Classic mistake.
Precisely. He should have focused on a solid game loop first. Then, onto his second project, Clarity Corp, a puzzle simulation game. Think, Papers, Please meets The Matrix. This one, however, lacked a compelling hook. He couldn't quite nail down what made it fun.
Ah, the elusive fun factor. That's the hardest thing to quantify, isn't it? It's all about that core loop. So he abandoned that one?
Essentially, yes. He parked it for now. Then came his third project, a co-op side-scrolling shooter, inspired by Celeste, Broforce, and Remnant. This one seems more manageable in scope, with a simplified art style. But even here, he faces challenges like real-time multiplayer, level design, boss fights, and playtesting.
Real-time multiplayer adds a whole new layer of complexity. Client-side prediction and lag compensation, those are tricky beasts to tame. But it sounds like he's learned a lot from his previous failures.
Exactly. His key takeaways are spot on. Multiplayer is tough but rewarding. Start small, know your limits, solid game loops are crucial, and polish comes later. He's not discouraged. He's excited to apply these lessons in 2025. He's got a great attitude.
I love his perspective. It's a reminder that game development is a journey, not a race. It's about the learning process as much as the finished product. A great story for aspiring game developers.
Absolutely. And that's a wrap for today's Tech Bytes and News. Thanks for joining us. We hope you enjoyed this insightful discussion. Bye for now.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into Cerebra's incredible achievement, achieving comparable yields on a wafer-scale chip 50 times larger than the biggest GPS. It's mind-blowing, isn't it?
Absolutely. I mean, the conventional wisdom has always been that bigger chips equal worse yields. How did Cerebras seemingly break the rules of physics, or at least semiconductor physics?
Well, it's not magic, but it's pretty darn close. They didn't just make a bigger chip, they completely rethought the relationship between chip size and fault tolerance. It's all about the size of the individual cores, you see.
Smaller cores? Explain that to me like I'm 5. Or, someone who understands transistors but not necessarily wafer-scale integration.
Okay, imagine building with Legos. A huge Lego castle is more likely to have a few broken bricks than a small Lego car, right? Each core is like a Lego brick. Cerebras made their bricks, their cores, incredibly tiny. So even if a few are defective, it's a tiny fraction of the overall chip.
I see. So, more cores, smaller cores, more fault tolerance. But that's not the whole story, is it? They mention a sophisticated routing architecture.
Exactly. It's not just about having tiny cores, it's about how they're connected. Think of it like a road network. If one road is blocked, you can reroute traffic. Cerebra's system dynamically reroutes around faulty cores, using redundant pathways. Clever, huh?
Incredibly clever. And they have a reserve of spare cores, too, acting as backups. It's like having extra lanes on the highway for when there's an accident. So they're not just tolerating defects, they're actively working around them.
Precisely. They cleverly combined tiny cores with a robust routing system and a small pool of spares. It's a holistic approach to defect tolerance, not just a single solution, and the results are stunning.
Stunning indeed. The article compares their wafer-scale Engine 3 to an NVIDIA H100. The difference in defect tolerance is, well, it's off the charts. 100x more fault-tolerant, they claim.
Yeah, the numbers are jaw-dropping. The H100, while massive, loses a significant chunk of silicon area to defects. The Cerebras chip, despite being vastly larger, loses a tiny fraction. It's a testament to their design. They achieve 93% silicon utilization, higher than the leading GPU.
That's almost unbelievable. So it's not just about making a bigger chip, it's about making a bigger, more resilient chip. It changes the game, doesn't it?
It absolutely does. It opens up possibilities we haven't even imagined yet. Wafer-scale computing was once a pipe dream, limited by yield issues. Cerebras has not only made it a reality but has made it commercially viable. This is a huge leap forward for AI and high-performance computing.
Absolutely. This is a game changer. Thanks for breaking down this fascinating article for us. It's inspiring to see such innovative solutions to long-standing problems.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for more exciting breakthroughs in the world of technology. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into the thrilling success of Blue Origin's New Glenn rocket. It's a monumental achievement, folks.
A Saturn V-sized rocket reaching orbit? That's insane. I read the Ars Technica article. The launch was delayed, right? Engine chill issues, if I recall correctly?
You got it. Apparently, those BE-4 engines were a bit warmer than expected. Think of it like trying to start your car on a scorching summer day. It's just not as easy. But, they persevered.
And then there was a rogue boat. A real-life nautical nuisance disrupting the countdown. Talk about a last-minute snag. I mean, seriously, a boat?
A boat! It's like something out of a slapstick comedy, isn't it? But hey, they managed to clear the area, and New Glenn finally blasted off at 2:03 a.m. Eastern Time. Talk about a dramatic launch.
So the launch itself went smoothly then? Did it reach orbit?
Oh, it reached orbit all right. The first stage burned for over 3 minutes. Then the second stage took over, firing its BE-3U engines for almost 10 minutes. They hit an orbital velocity of 28,800 kilometers per hour. Amazing!
That's incredibly fast. But I thought I read something about the booster not making it back?
Yeah, unfortunately they lost the booster. The drone ship, the Jacqueline, was waiting, but it was a lonely vigil. But, it's their first orbital flight. SpaceX didn't land their first orbital booster until their 19th launch. It's a huge undertaking.
True, it's a massive accomplishment just to reach orbit on the first try. Still, I'm curious about the scale of this rocket. The article mentions it's Saturn V-sized. That's a bold statement.
It is. It's a testament to their ambition. It's a super heavy lift vehicle, largely privately funded. Jeff Bezos has poured billions into this project, and it seems to have paid off spectacularly, at least in terms of reaching orbit.
Billions. That's a serious investment. So overall, a resounding success for Blue Origin, even with the booster loss and the pre-launch hiccups. A truly remarkable feat of engineering. What a story.
Absolutely. A triumph against the odds, a testament to human ingenuity and perseverance. And a great day for space exploration. Thanks for joining us on Tech Bytes and News. We'll see you next time for more exciting tech news.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into the surprisingly murky world of web-safe fonts. Prepare for a font-tastic adventure.
Oh boy, here we go. I always assumed Arial and Times New Roman were like the ultimate safe bets. What's the big deal?
Well, the big deal is, there's no such thing. The whole concept of web-safe fonts is, frankly, a myth. The idea that certain fonts are guaranteed to be on every system is just plain wrong.
Whoa, seriously? Even Arial and Times New Roman? I'm reeling. What's the evidence?
The evidence is scattered, but compelling. Even those stalwarts, Arial and Times New Roman, are absent on some Android versions apparently. And get this, Courier New, not available on iOS. Can you believe it?
No way. Courier New? That's like a foundational font. So what's the solution? Do we just give up and use web fonts exclusively?
Not exactly. The solution is to embrace the reality of font diversity and use multiple fallbacks. The article highlights a website using a web font for headings, but with local Courier and Menlo fallbacks. Clever, right?
But wait, you mentioned a Menlo regular fallback? Why not just Menlo? Is that like a font family thing?
Precisely. Menlo, it turns out, is a collection of fonts, not a single font. It's a whole font family, a TTC, a true type collection. So specifying Menlo regular ensures you get the specific font you're after. It's like choosing a specific flavor of ice cream, instead of just saying, ice cream.
I see. So it's all about managing expectations and building in robust fallbacks. This completely changes my approach to font selection. Thanks for clearing that up.
Absolutely. The key takeaway is to ditch the outdated notion of web-safe fonts and instead focus on building a reliable fallback strategy. Embrace the chaos, and your fonts will thank you.
I'm already brainstorming fallback strategies for my next project. This has been incredibly enlightening.
That's the spirit. And remember, folks, there's no such thing as a truly web-safe font, only well-planned font fallbacks. Thanks for joining us on Tech Bytes and News. We'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a provocative piece titled, Nobody Cares. A fascinating rant, really, exploring why so many things in our world seem suboptimal, to put it mildly. Let's get started.
I'm intrigued. Is this a tech-focused rant or something broader? I'm bracing myself for some strong opinions.
Oh, it's definitely broad, but the tech angle is there. Think buggy software, poorly designed infrastructure, the whole shebang. The author starts with the DMV classic and then moves on to software, municipal governments, and even bike lanes. It's a real roller coaster of frustration.
A roller coaster of frustration? I like the sound of that. So what's the core argument?
The core argument is simple. Nobody cares. People, from programmers to city bureaucrats, seem content to deliver subpar work, even when a tiny bit more effort would yield massive improvements. He uses the example of a terribly designed bike lane that ends abruptly at a sharp angle, causing accidents. It's infuriating, really.
So it's not about lack of resources, but lack of motivation?
Exactly. He interviews programmers from a large healthcare company, and they prioritize job security over creating a good product. It's a systemic issue, not just individual laziness. He even mentions Seattle's switch to harsh white LEDs, which are terrible for sleep, but good for reducing car crashes by 0.1%. The cost-benefit analysis is skewed because they don't factor in the impact on people's sleep.
That's a great point. So is he advocating for some kind of revolution? A global care initiative?
Not exactly a revolution, more of a lament. He contrasts his current job at a small startup where everyone cares deeply with his previous experience at a big tech company where apathy reigns supreme. He even talks about installing dog waste bag dispensers in his neighborhood, hoping to inspire a snowball of care, but it didn't work. It's a bit heartbreaking, actually.
Heartbreaking, but relatable. I've definitely encountered that nobody cares attitude in various contexts. But is there a solution offered?
He doesn't offer a concrete solution, more of a longing for a community where everyone cares, citing Japan as an example of a society where people seem to take more pride in their work and their roles in society. He wonders if such a community exists in the U.S., or if it needs to be built. It's a thought-provoking question, isn't it?
It really is. It's a fascinating exploration of apathy and the desire for a more engaged society. A bit cynical, but also quite insightful. Thanks for summarizing this interesting article.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into DNSPYEX, the unofficial resurrection of the renowned .NET debugger and assembly editor, DNSPY. Get ready, because this is a powerful tool.
Ooh, sounds intense. So what makes DNSPYEX so special? Is it just a simple update, or is there something more to it?
Oh, it's way more than a simple update. Think of it as a phoenix rising from the ashes, more powerful and feature-packed than ever. It's a complete continuation of the original DNSPY project, picking up where it left off and adding even more amazing capabilities.
I see. So what are some of these killer features? I'm particularly interested in the debugging aspect.
Absolutely. The debugging features are insane. You can debug .NET Framework, .NET, and even Unity game assemblies, all without needing the source code. Imagine that. Stepping through code you didn't even write.
That's mind-blowing. But wait, there's more, right? The description mentions editing assemblies too. How does that work?
Yeah, the editing capabilities are equally impressive. You can edit methods and classes directly in C# or Visual Basic, with IntelliSense no less. It's like having a full-fledged IDE built right into the debugger. Plus, there's an IL editor for those who like to get down and dirty with the low-level stuff.
Wow, that's a serious upgrade from just viewing the code. So if I want to get my hands on this, where do I find it?
Great question. You can grab the latest stable release directly from their GitHub releases page. But if you're feeling adventurous, you can also try out the beta builds from their GitHub Actions workflow. Just remember, betas can be a bit unstable.
Understood. And what about building it myself? I'm a bit of a tinkerer.
Absolutely. The instructions are on their GitHub page. It's a pretty straightforward process, especially if you're familiar with Git and PowerShell. Oh, and if you're planning on debugging Unity games, you'll need to grab their separate DNSPY Unity mono repository as well.
Got it. One last question. This sounds incredibly powerful. Are there any limitations I should be aware of?
Well, there are a few. For example, while you can debug dynamic modules, dynamic methods are a bit trickier due to CLR limitations. But overall, it's a remarkably capable tool, and the community is quite active, so if you run into any snags, you're likely to find help quickly.
That's reassuring. Thanks for the rundown. This DNSPYEX sounds like a game changer for reverse engineering and .NET development.
My pleasure. And remember, folks, DNSPYEX is licensed under the GPL v3, so it's completely open source and free to use. Happy debugging and editing. And that's all the time we have for today's Tech Bytes and News. Until next time, goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating personal note from Nate Anderson, the founder of Hindenburg Research, announcing the firm's disbandment. It's a really emotional and surprisingly inspiring read.
I saw this on Hacker News too, and it's not your typical corporate announcement. It's incredibly personal and honest, almost vulnerable. What struck you most?
Yeah, the raw honesty is what got me. He talks about his self-doubt, his financial struggles, even facing eviction while starting the firm. He didn't have a traditional finance background, no connections, no money, just pure grit. Amazing.
Totally. He paints this picture of starting with almost nothing, relying on the support of a whistleblower lawyer to even get off the ground. That's a pretty incredible underdog story. And the way he describes his team.
Yes, he calls them ruthless assassins, but in the nicest way possible. They're all incredibly talented, but came from unconventional backgrounds. A former bartender, for instance. It's a testament to his ability to spot talent and build a team that shares his vision. It's inspiring.
And the impact they've had. Nearly 100 individuals charged, including billionaires and oligarchs. That's not just a success story. It's a testament to the power of diligent investigative work and holding powerful people accountable.
Exactly. But it wasn't without its challenges. He talks about the intense pressure, the sleepless nights, the constant stream of investigative threads popping into his head, even in his dreams. It sounds utterly exhausting.
Yeah, it does. I mean, the guy's clearly driven, but it also sounds like he's finally reached a point of burnout, or at least a desire for a different kind of fulfillment. He mentions that a successful career can become a selfish act. I found that interesting.
I see what you mean. He's found a level of self-acceptance and comfort he didn't have before, and now he sees Hindenburg as a chapter, not his whole identity. He's ready to move on, and I think that's okay. It's a healthy realization.
And the plan to open source their methodology is brilliant. It's a way to give back, to empower others to continue the fight against fraud and corruption. It's a legacy beyond the firm itself.
Absolutely. He's hoping someone will pick up the torch, and I think that's a beautiful way to end this chapter. It's not just about winding down Hindenburg, it's about inspiring the next generation of investigative journalists.
It's a really powerful message, and a really unique way to announce the end of a company. It's more of a love letter to his team, his family, and his readers. A very human story.
It is. And that's what makes it so memorable. It's a reminder that even in the world of high-stakes finance, human stories and emotions matter now. And that sometimes, the greatest success is knowing when to step away and let others carry the flame. Thanks for joining us on Tech Bytes and News. We'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into Apache Data Fusion, a seriously impressive query engine. It's written in Rust, which, let's be honest, is already a win.
Rust? Sounds intense. So what makes Data Fusion so special? Is it just the cool language choice?
Oh, it's way more than just the Rust. It uses Apache Arrow as its in-memory format, which means blazing fast performance. Think of it as the Ferrari of query engines. Sleek, powerful, and built for speed.
Ferrari, I like that. But what can you actually do with it? I mean, beyond just impressing your friends with your knowledge of Rust and Arrow.
Ha! Well, it's got SQL and DataFrame APIs, so you can query data like a boss. It supports CSV, Parquet, JSON, and Avro out of the box. It's incredibly customizable too. You can add your own data sources, query languages, functions. The works!
Hold on, customizable? Does that mean I can, make it speak Klingon?
Theoretically? Maybe? I haven't tried it, but the level of customization is pretty insane. They've got a full query planner, a columnar, streaming, multi-threaded, vectorized execution engine. It's a beast.
Okay, I'm impressed. But what about scalability? Can it handle, big data?
Absolutely. They have Data Fusion Ray, a distributed version that scales out on Ray clusters, so you can handle petabytes of data without breaking a sweat. Plus, there's Data Fusion Comet, an accelerator for Apache Spark. It's like Data Fusion on steroids.
Steroids? Sounds intense. So where do I even start? Is there a good tutorial or something?
Totally. They have a fantastic user guide with example usage and even a library user guide if you want to dive into the extension APIs. There's also a developer's guide if you're feeling adventurous and want to contribute. Plus, they have a great community, so you're not alone in this journey.
This sounds amazing. I'm already picturing myself building the next generation of data analytics tools with Data Fusion. Thanks for the overview.
My pleasure. Remember to check out the links in the show notes for all the resources we discussed. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating paper, Titans, learning to memorize at test time. It's all about a new neural architecture that's really shaking things up in the world of long-term memory in AI.
2 million context window size? That's insane. So, what's the core idea behind Titans? Is it just another attention mechanism or something more radical?
It's more than just another attention mechanism. It's a whole new paradigm. See, for years we've been wrestling with the limitations of recurrent models and attention. Recurrent models, they try to cram everything into a tiny hidden state, like trying to fit an elephant into a shoebox.
Yeah, I get that. Limited capacity. And attention, while powerful, is quadratically expensive, right? The context window size is always a bottleneck.
Exactly. Attention's great at capturing dependencies, but it's like having a super powerful microscope that can only look at a tiny area at a time. Titans cleverly combines a short-term memory, attention, with a long-term memory module. This long-term memory learns to memorize historical context, allowing the attention mechanism to focus on the present while still leveraging past information. It's like having both a detailed map of your immediate surroundings and a broader overview of the entire region.
So it's a hybrid approach. That's clever. But how do they achieve fast parallelizable training and fast inference? That's usually a trade-off.
That's the beauty of it. The design allows for efficient parallelization during training, speeding things up considerably. And, importantly, inference remains speedy, which is crucial for real-world applications. They've really cracked the code on this one, you know?
The paper mentions 3 variants of the Titans architecture. Are those just different ways of integrating the memory module?
Precisely. They explore different ways to effectively incorporate this long-term memory into the architecture, each with its own strengths and weaknesses. It's a really thorough investigation. The results are pretty impressive across various tasks: language modeling, common sense reasoning, genomics, even time series analysis. They even managed to scale to a context window of over 2 million tokens.
2 million! That's a game changer for tasks like needle in haystack searches, where you need to sift through massive amounts of data. But, I'm curious, what are the limitations? Is this a perfect solution?
Well, no solution is perfect. While Titans show significant improvements, there's always room for further research. The complexity of the architecture might pose challenges for smaller datasets or less powerful hardware, but the potential benefits are huge.
I see. It's a significant step forward, but like all advancements, it opens up new avenues for exploration and improvement. It's exciting to see this kind of innovation in the field.
Absolutely. This paper is a real game changer, pushing the boundaries of what's possible with long-term memory in neural networks. It's a must-read for anyone interested in the future of AI. Thanks for joining us on Tech Bytes and News. We'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into a juicy tech battle: Apple versus the EU's Digital Markets Act. It's a clash of titans.
Oh boy, here we go again. Apple and regulations, a love-hate relationship, right? So what's the latest drama?
Exactly. Several advocacy groups, including the Free Software Foundation Europe, are clawing at Apple, claiming its interoperability efforts under the DMA are, shall we say, lacking. They're not just failing to meet the letter of the law, but the spirit too.
Lacking? That's putting it mildly. What specific issues are they highlighting?
Well, they've got a whole laundry list. First, they're furious about Apple's use of NDAs, non-disclosure agreements, with developers. They say Apple uses these NDAs to stifle interoperability efforts, and they want the EU to review these agreements on a case-by-case basis, not just let Apple have free rein.
I see. So Apple's using NDAs as a way to keep things hush-hush and prevent competition? Sneaky.
Precisely. And that's not all. They want a standardized interoperability request form. Currently, it's a bit of a wild west out there, and developers complain about opaque processes and delaying tactics from Apple.
A standardized form sounds reasonable. More transparency is always a good thing, especially when dealing with a company as powerful as Apple. What else?
Well, they're also challenging Apple's reliance on security by obscurity. They argue that Apple shouldn't be allowed to hide details of its frameworks and libraries under the guise of security. They believe developers should be able to demonstrate interoperability based on open standards and public documentation, and Apple should have to prove otherwise.
That's a pretty bold challenge. I mean, security is important, but it shouldn't be used as a shield to block competition. What's Apple's counter-argument?
Oh, Apple's response is, interesting. They published a document claiming that the DMA's interoperability requirements could expose user data, specifically citing Meta's numerous requests for access to Apple's technology stack. They argue that granting Meta access would compromise user privacy.
So Apple's playing the privacy card again? A classic move. But is that a valid argument?
That's where it gets really interesting. Meta's response was essentially, Apple's using privacy as a smokescreen to avoid complying with the DMA. It's a he said, she said situation, and the EU is left to sort it out.
It's a fascinating cat and mouse game, isn't it? So what's the likely outcome here?
Well, it's hard to say for sure. The EU has already opened proceedings against Apple, and these advocacy groups are pushing for stronger action. It's a complex situation with significant implications for competition and innovation in the tech world. We'll have to wait and see how the EU responds.
Indeed, a real nail-biter. Thanks for breaking down this complex situation for us. It's certainly a story to keep an eye on.
Absolutely. And that's all the time we have for today's Tech Bites and News. Thanks for tuning in, and we'll catch you next time with more exciting tech news. Goodbye.
Bye-bye.
Welcome to Tech Bites and News, your daily roundup of articles featured in Hacker News. Today we're diving headfirst into the fascinating world of Ashburn, Virginia, and its unlikely claim to fame, being the data center capital of the world. Prepare to be amazed.
Whoa, the data center capital? That sounds intense. What makes Ashburn so special? Is it like some kind of underground server lair?
Not quite a lair, but close. It's a confluence of factors, really. First, the land was relatively cheap back in the day, a total steal compared to today's $1 million an acre prices. Then there's the electricity, 20% cheaper than the national average.
20%? That's a huge saving, especially considering how much power data centers gobble up. I read that data centers consume a significant chunk of global electricity.
You got it. It's a massive energy hog. But Ashburn's low electricity costs make it a financially attractive location. Plus, it's near a highly skilled workforce, thanks to government tech contracts and a booming local economy. It's a perfect storm of factors.
I see. So it's a combination of cheap land, cheap power, and a skilled workforce. That makes a lot of sense. But how did it get to be 70% of the world's internet traffic? That's insane.
Exactly. It's a snowball effect. Early adopters like AOL set up shop, then Verizon, and soon the mega giants like Amazon, Google, and Microsoft followed suit. Each new data center attracted more connectivity, creating a massive, interconnected ecosystem.
So it's like a digital gold rush, but instead of gold, it's data? And the local government is helping, right, with tax breaks and incentives?
Absolutely. Loudoun County gets it. They've got a fast-track commercial incentive program, tax exemptions. The works. They realize that data centers are a major economic driver. They're not just letting it happen. They're actively encouraging it.
Smart move. And what about the future? Is Ashburn's reign as data center king secure? Are there any challenges on the horizon?
Well, there's always the issue of scaling. They're building taller data centers to maximize space, even demolishing existing buildings to make way for more servers. And there's the competition. Other regions are trying to catch up. But for now, Ashburn's dominance seems pretty solid. They've got the infrastructure, the workforce, and the government support.
It's truly remarkable how this small town in Virginia became the center of the digital universe. Thanks for breaking it down for us.
My pleasure. And remember, listeners, if you're looking for a place to store your terabytes, Ashburn is the place to be. Join us next time on Tech Bytes and News for more fascinating tech insights. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into the wonderfully weird world of software folklore. It's a collection of unbelievably bizarre bugs, the kind that make you question the very fabric of reality. Prepare to be amazed.
Oh, I'm already hooked. So what kind of unbelievable bug stories are we talking about here?
Well, we've got a car allergic to vanilla ice cream. I'm not even making that up. Then there's the case of the Crash Bandicoot. Not the game, but a real-world software crash that apparently only happened under specific conditions.
A car with a vanilla ice cream allergy? This is getting better by the second. Is this some kind of metaphoric thing, or are we talking actual, documented software glitches?
Oh, these are real, documented glitches. We're talking about things like software that crashes only on certain moon phases, or a train that stops when someone flushes a toilet. It's insane.
Wait, a toilet flushing stopping a train? That's a whole new level of bizarre. I'm guessing there's some kind of shared resource issue, some kind of incredibly unlikely coincidence of timing, or maybe a faulty sensor somewhere?
I see. Interesting. You're thinking logically, which is great, but these stories often defy logic. There's also one about a gateway computer that seemed to hate Fortran code, refusing to run programs written in it. Pure software prejudice.
Software prejudice? Ooh, that's hilarious. I mean, I've seen some weird bugs, but this is a whole new level of weird. What's the most mind-bending one you've seen?
That's tough. There are so many. But I think the packets of death story is up there. It's a story about, well, packets of data that cause crashes. Could share. It's a bit technical, but the sheer unexpectedness of it is amazing.
Packets of death. Sounds ominous. I'm guessing it's some kind of network issue? A buffer overflow or something? Something that exploits a vulnerability in the system?
Got it. You're getting warmer, but the details are... Well, let's just say they're as unexpected as the vanilla ice cream allergic car. There's also a story about an email that traveled 500 miles. Not figuratively, literally. And another about OpenOffice refusing to print on Tuesdays.
500 miles? An email that somehow physically traveled 500 miles? Is this some kind of bizarre routing error? Or a prank? This is getting more and more surreal. I need to hear more of these crazy stories.
There are many more. The collection includes stories about iPhones being allergic to helium, a word processor that formatted hard drives, and even a self-fixing internet outage. It's a goldmine of bizarre software glitches. And the best part? You can submit your own stories.
This is incredible. I'm definitely going to check out this collection. Thanks for sharing these amazing, unbelievable stories. This has been a truly enlightening and entertaining episode.
You're very welcome. And that's all the time we have for today's episode of Tech Bytes and News. Join us next time for more fascinating tech news and discussions. Goodbye, everyone, and have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a seriously exciting opportunity. A software engineering internship at Empirical Health, a Y Combinator company. Get ready, folks, because this is a game changer.
$8,000 a month? That's not chump change. What's the catch? Is it a soul-selling pack to build sentient health bots?
Haha, no soul selling involved, I promise. It's a 12-week summer internship, starting sometime in May or June, focused on building the future of proactive primary care using AI and wearable tech. Think Apple Watches, Fitbits, the whole shebang. They're aiming to prevent hospitalizations using AI-powered personal health assistants, all backed by real doctors. Pretty ambitious, right?
Ambitious is an understatement. So what kind of projects are we talking about? Building a Skynet for your blood pressure?
Not quite Skynet, but close. They're looking for interns to work on machine learning models to predict hospitalizations, using data from wearables and health records. Imagine building a system that can flag patients at risk. That's life-saving stuff. Plus, there's the mobile app side, designing new features to improve AI-generated care plans for conditions like POTS or sleep apnea.
Wow, that's impactful. So what's the tech stack like? Are we talking ancient COBOL or something cutting edge?
Cutting edge, my friend. We're talking React Native for the mobile app, Node.js on the server side, all powered by TypeScript, PostgreSQL for the database, and Python for the data science and machine learning bits. It's a modern, robust stack.
Sounds like a dream internship for the right candidate. But what are they looking for in an intern? Besides the obvious coding skills, of course.
Besides the usual suspects, strong TypeScript or JavaScript, React or React Native, and or Python skills, they're looking for someone with a genuine desire to make a difference in healthcare. Someone with a sense of design, someone who values clean code, automated tests, and quick iteration cycles. They also want someone with a strong owner's mindset, someone who takes initiative and gets things done.
So basically, a coding ninja with a heart of gold. And what about the interview process? Is it a gauntlet of fire-breathing dragons and coding puzzles?
Haha, not quite dragons. It's 2 45 to 60-minute technical interviews. The first one starts with a 15-minute getting to know you section to assess culture fit, followed by a technical deep dive into data structures, algorithms, and system design. So brush up on those skills.
And the compensation? Did I hear $8,000 a month? Plus free lunch? I'm suddenly very interested in this internship, even if I have to learn POTS.
That's right, $8,000 a month, free lunch, in-person mentorship, and all the coffee and events you can handle in their WeWork office. It's a pretty sweet deal. And yes, you'll probably learn about POTS along the way. It's all part of the adventure.
So, to summarize, a high-impact internship at a Y Combinator company using cutting-edge tech to revolutionize healthcare, with excellent compensation and perks. Sign me up.
Exactly. If you're a talented software engineer with a passion for healthcare and a desire to make a real impact, this is your chance. Check out the link in the show notes for more details and to apply. And that's all the time we have for today. Thanks for tuning in to Tech Bytes and News. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating story from Sweden. A return to the old school in their tech-heavy schools. It seems the digital revolution in Swedish classrooms might have hit a bit of a snag. Or maybe a very well-placed, well-deserved textbook.
A textbook, you say? Intriguing. I'm all ears. What's the gist? Is Sweden ditching tablets altogether?
Not quite, but they're definitely dialing back the digital intensity. It seems their years-long push for digitalization, even in preschools. Imagine toddlers with tablets, is facing some serious pushback. Apparently, test scores in reading aren't what they used to be.
Oh, so it's a case of too much screen time, not enough reading comprehension? I see. That sounds like a pretty common problem, actually. What's the Swedish government doing about it?
The education minister, Lotta Edholm, has been a vocal critic, championing a return to physical textbooks. She even announced a massive investment, 685 million kroner, to get more books into schools. That's serious money.
Wow, that's a lot of kroner. 60 million euros. So it's not just about the tablets then, it's also about getting kids back to reading actual books?
Exactly. And it's not just books. They're also emphasizing handwriting practice. Think of it as a digital detox with a side of cursive. The irony is delicious.
I find that interesting. Handwriting. It's almost a lost art in many places. Is there a real educational benefit to this, or is it just nostalgia?
Well, the Karolinska Institute, a pretty reputable medical research school, actually weighed in, saying there's evidence that digital tools can impair learning, not enhance it. They suggest a return to traditional methods. Though, I'd like to see the methodology on that one.
That's a bold claim. Technology has so much potential. It's not like they're saying ban all technology, right? There's a nuanced approach here, I'd imagine.
You're right, it's not a complete ban. It's more of a rebalancing act. They're not saying no screens ever, but they are saying less screens, more books, and definitely more pencil-to-paper practice, especially for younger kids. It's also interesting to note that UNESCO also recently put out a report warning against over-reliance on technology in education.
I see. So it's a global trend then, a kind of backlash against the digital-first approach to education? It makes sense, there's a lot to be said for the tactile experience of reading a book, the feel of a pen in your hand.
Absolutely. And it's not just Sweden. The article mentions similar debates in the US and Germany, highlighting different approaches and challenges. The US, for example, has a digital divide to contend with, while Germany is famously slow to adopt digital solutions in general. It's a whole fascinating mess.
It really is a complex issue. There's no easy answer, is there? It's a balancing act between embracing technology's potential and recognizing the value of traditional methods. It's a delicate dance between the digital and the analog.
Precisely. And Sweden's experiment, with its significant financial investment, will be interesting to watch. Will this back-to-basics approach actually improve reading scores? Only time will tell. But one thing's for sure, it's a conversation worth having. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Swedish education. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of imaging-mounted disk volumes, even under pressure. Think of it as a digital heart transplant, but way cooler. Way cooler.
Sounds intense. So what's the core problem this blog post tackles? Is it about backing up systems without downtime?
Exactly. The author, Ben Jojo, faces the age-old problem of needing a bootable backup of a system that doesn't have fancy snapshot features like LVM, DRBD, or MD, the kind of systems that make you want to scream into a pillow. Or maybe just a little.
I get it. No fancy backups, imminent system failure, the classic IT nightmare. So what's the proposed solution? Is it some kind of magic?
Close. It's not magic, but it's pretty darn clever. The solution leverages the often overlooked "BLK trace" utility, a Linux tracing API from 2006. It's like a super-powered system monitor that tracks every single block device operation. Amazing!
Wait, a 2006 API? That's ancient. Why hasn't this been used more?
Yeah, that's what Ben Jojo points out. It's a bit of a mystery. It seems like it's been largely unused outside of HP's internal SAN debugging. Maybe they kept it secret? Maybe it was a secret weapon. But it's incredibly useful for this specific problem.
So how does "BLK trace" help with imaging a live system? Doesn't "DD" already do that?
"DD" is great, but it has a flaw. If the system is writing to the disk while "DD" is reading, you end up with a corrupted image. "BLK trace" solves this by tracking those writes in real time. It's like having a live feed of the disk's activity. Brilliant!
Okay, I'm following. So, "BLK trace" shows which sectors are being written to, and a custom tool can then go back and grab those changes after the initial image is created?
Precisely. Ben Jojo built a tool called "hot clone" that uses this information to create a perfectly consistent image, even with ongoing writes. He even goes through a rigorous test to prove it works, using a delightfully slow hot pink USB drive. A hot pink USB drive.
A hot pink USB drive? That's the best part of this whole thing. But seriously, what are the limitations? Is this a silver bullet for all backup needs?
Not quite a silver bullet. It's a very niche solution for situations where you can't use traditional block-level snapshots. It requires some technical know-how, and it uses memory to track dirty sectors. About 250 megabytes per terabyte of disk space. But for those specific scenarios, it's a lifesaver.
So a powerful tool for a specific problem. A bit of a hidden gem, resurrected from the depths of a 2006 API. I love it. Where can our listeners find this amazing tool and the blog post?
You can find the "hot clone" tool, source code, and pre-built binaries on GitHub at github.com/benjojo/hot-clone. And the blog post detailing this whole process is at blog.benjojo.co.uk/post/imaging-mounted-disk-volumes-live. It's a great read, and don't forget to check out Ben Jojo's other work.
Definitely worth checking out. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of live disk imaging.
Thanks for listening, everyone. Until next time, stay techy. Bye.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.